definitely enough theory. Let's see SVD in action and recommend some movies with it. So open up Spider. And close out any existing windows so we don't get confused. A shortcut for that, by the way, is Control-Shift-W. Open up everything inside the Matrix Factorization folder inside your course materials. Let's start by looking at the svdbakeoff.py file. SurpriseLib includes a couple of different SVD implementations. One is SVD, more or less as we've described it. The other is called SVD++. It's a slight variant of SVD that ended up being part of the winning system for the Netflix prize. The difference is fairly subtle. It has to do with the actual loss function that is used while running stochastic gradient descent. In SVD++, this loss function takes into account the idea that merely rating an item at all is some sort of implicit interest in the item, no matter what the rating was. But that was enough to make SVD good enough to win. There's not much to talk about in the code itself. The actual implementation of SVD and SVD++ is handled by the library. You can look at SurpriseLib in GitHub if you want to see how the code works under the hood, but it's way too complex to walk through right now. When you start dealing with algorithms as complex as SVD, it's almost never a good idea to write it from scratch yourself. Use third-party open source libraries that have been used and validated by others instead. The odds are just too great that you'll mess up some tiny thing that ruins your results somehow. So let's go ahead and kick this off and see what sort of results we get. It will take several minutes to run, so we're just going to pause and come back when it's done. SVD++ in particular takes some time. Well, these accuracy results are the best we've seen so far, and as expected, SVD++ is a little bit better, actually getting below 0.9 RMSE. That's pretty impressive as accuracy goes. But what did the actual top-end recommendations look like? Let's scroll down and take a look at SVD first. Okay, these don't look too bad. Gladiator, Moon, Wallace and Gromit, those are all movies I enjoyed, and recall that I selected our test user as someone who has similar taste to myself. Many of the other results are movies that are literally on my list of movies I want to watch. So on the surface, it seems that the SVD recommender did a pretty good job of recommending a mix of movies I know about that give me trust in the system, and recommending somewhat more obscure titles that I'm genuinely likely to enjoy. This seems like something worth testing on real people for sure. The difference in accuracy with SVD++ was subtle, so I wouldn't expect to see any big changes in its results, but let's see. Well, we do see a few of the same movies that SVD came up with, but we see a few new ones too, like Harry Potter and Indiana Jones. If User85 really hasn't seen those movies yet, I'm kind of amazed that they haven't come up before. So all things being equal, SVD++ seems like the one I'd experiment with first. I like these results. It seems like something good is happening here. That's the thing with algorithms that extract latent factors. They can be a little bit spooky in how well they distill users down to their fundamental interests and how well they distill movies into what makes them unique. Matching the two up with SVD can be a powerful idea. That was a lot of theory to wrap your head around, but we got a pretty good payoff for it here.